So someone asked about section 12.2, number 12. This does get asked every time, so I figured I might as well make a video of it. So we're finding the magnitude of the resultant force, which just means the total force if there's these two forces pulling on it, A and B, in these two directions. And then we also want to find the angle it makes with the positive x-axis. So what's happening? This thing is getting pulled this way and also up, so it's probably going to move like this way or something like that. So what happens to the forces? The vectors get added. So it doesn't matter where I put A, right? I can put it here. Position doesn't matter. Magnitude and direction do. So that's 60 degrees. And then I need to find this vector. So we've got a tip to tail adding. We're walking this way, then this way, and in total, we've walked this way. Okay, so let's figure out what the magnitude of that is. Well, we have B is 300 newtons, and A is 200 newtons. So to find, I don't actually think I've solved this problem this way before, but now we have a right angle triangle, so maybe we'll do the law of cosines. That's a bit of a unconventional way to do this, but sure, we need to find the magnitude. Let's call it m. So then m squared is 200 squared plus 300 squared minus 2 times 200 times 300 times the cosine of 60 degrees. I wonder if that's wise. All right, whatever. So then we need to type all that into a calculator because, or do I need to type it into a calculator? No, cosine of 60 degrees is 1/2, so it's not so bad. So, okay, so I'm going to factor out a 100 squared. See if I can avoid doing this with a calculator. 4 plus 9 minus 2 times 3. Cosine of 60 degrees is 1/2. That's great. Okay, so m squared is 100 squared times this is 13 minus 6 is 7. So m is 100 root 7. We can actually get an exact value for that. They do want you to round to one decimal place, so let's do that. 100 times root 7 is going to be about 264.6. You might have different numbers than me, so maybe this isn't helpful. Okay, and then we need to find the angle it makes with the positive x-axis. That is that angle in gray. I'm going to go ahead and solve for this angle, and then we'll be able to do 180 minus that. Okay, so I've never done this question this way before. This is funny. Let's do law of sines. Sine theta over 200 is angle is 180 degrees minus theta. Okay, sine theta over 200 is sine 60 over m, which we know is 100 root 7. So sine theta is root 3 over 2 times 2 over root 7. That's fun. All of these are in exact values. Sine inverse of root 3 over root 7. So we've got to figure out what that is in degrees. Make sure your calculator's in degrees. For this, and then I need a sine inverse. Does my calculator do sine inverse? It does. Okay. I almost thought it didn't. Root 3 over root 7. Okay, so I'm getting about 40.9 degrees for theta, meaning that the other angle is 180 minus that, 139.1. About 139.1. Hopefully that's correct. It may not matter too much since you might have different numbers for me. But But yeah, there's that problem. The trig stuff is not important. The important thing is to know how to visually add two vectors. That's the important thing for this course.